Hello everyone, welcome to our video lesson in solving oblique triangles using the law of sines with a focus on the SSA case. After you watch this video, you're expected to determine the number of triangles formed when two sides and an angle opposite one of the sides are given. Solve problems involving oblique triangles whose two sides and an angle opposite one of the sides are given, and develop perseverance when answering the activities. To begin with, let's answer the pre-test. Read each question carefully. Choose the letter that corresponds to the best answer. You have 10 seconds to answer each question. Number 1. Which of the following combinations can be solved using the law of sines? A. AAA, B. SAS, C. SSA, or D. SSS? Number 2. How many distinct triangles can be formed if A is 23, B is 19, and angle A is 50 degrees? A 0, B 1, C 2, or D more than 2? Number 3. For which value of A is it not possible to have triangle ABC if angle A is 30 degrees and B is 10? A 4, B 5, C 8, D 12. Number 4. In triangle ABC, A is 22, B is 12, and angle A is 42 degrees. What is the measure of angle B to the nearest 100? A. 21.41 degrees, B. 29.40 degrees, C. 116.59 degrees, or D. 150.60 degrees? Number 5. A triangular lot has sides 14 meters and 11 meters. If the third side makes an angle of 60 degrees with the shorter side, what is the length of the third side to the nearest meter? A. 15 meters, B. 16 meters, C. 17 meters, D. 18 meters. Let's check your answers. 1C, 2B, 3A, 4A, 5B. For our recap, let's answer this problem. Find the length of the altitude of triangle ABC below. To solve for the altitude of triangle ABC, which is represented by H, we use the sine ratio, which is opposite side over the hypotenuse. So we substitute H for the opposite side and B for the hypotenuse. Then solve for H. Then we substitute the values of B, which is 10, and angle A, which is 35 degrees. Then solve using your calculator. So H is equal to 5.74. Therefore, the length of the altitude of triangle ABC is 5.74. Don't forget that law of sines is a set of equations which connects the lengths of the sides of any triangle with the sines of the angles of the triangle. The triangle does not have to be right angled. for the law of sines to be used. In any triangle ABC with sides A, B, and C and opposite angles A, B, and C respectively, sine A over A is equal to sine B over B, which is equal also to sine C over C, or A over sine A is equal to B over sine B or C over sine C. The law of sines is still used to find the missing parts of an oblique triangle when the two sides and an angle opposite one of the sides, or the SSA, are given, but there are already several possibilities. On the following slides, the figures will illustrate the possible situations when the angle given is acute, obtuse, or right. Most of the time, it is assumed that the parts A, B, and angle A of triangle ABC are given, and the altitude H is opposite angle A. This is why H is equal to B times sine A. For the first case, angle A is an acute angle. So given that angle A is an acute angle and its opposite side, A, is greater than or equal to an adjacent side B, then there is only one triangle formed. Second, if angle A is an acute angle and its opposite side A is less than an adjacent side B, and when you check that A is equal to B times sine A, then there is only one triangle formed. For the third illustration, if angle A is an acute angle and its opposite side A is less than the adjacent side B, then you check that A is greater than B times sine A, then there are two triangles formed. And the fourth illustration is, if angle A is an acute angle and its opposite side A is less than an adjacent side B, and when you check that A is less than B times sine A, then there is no triangle formed. Please take note that any choice of variables could be used as long as you have satisfied the SSA case. Second case is angle A is an obtuse or right angle. So this is the first illustration. If angle A is an obtuse angle and its opposite side A is greater than an adjacent side B, then there is one triangle formed. However, if angle A is an obtuse angle and its opposite side A is less than an adjacent side B, then there is no triangle formed. Take note that any choice of variables could be used as long as you have satisfied the SSA case. Let's use these conditions to answer our examples. For example 1, determine the number of possible triangles formed with the given parts. So for letter A, angle A is an acute angle and A is less than B. Thus, we can use to compare A and B times sine A. So since 1P, which is A, is greater than the product of B sine A, which is 17.68, therefore there are two triangles formed. For letter B, angle B is an acute angle and B is less than C. Thus, B compared to C sine B, so we have 8 is less than 10.88. Therefore, there is no triangle formed. And letter C, angle A is obtuse and side A is greater than side B. Therefore, there is exactly one triangle formed. Example 2. So angle A is an obtuse angle and side A is greater than side B, thus there is exactly one triangle formed. Since A, B, and angle A are known, we can use the formula sine B over B equals sine A over A. Substitute the values, we cross multiply, divide both sides by 6. We solve for angle B using your calculator, so B equals 28.02 degrees. To solve for the third angle, angle C, we use the triangle sums theorem. So we substitute the values, combine similar terms, and subtract both sides of the equation by 138.02 degrees. So angle C is equal to 41.98 degrees. In solving side C, we will use sine A over A equals sine C over C. Then substitute the values, cross multiply, we divide both sides by sine 110 degrees. So use your calculator to solve for C. So C is 4.127. So this is now the triangle with complete measurements. For example 3, we're going to solve triangle ABC given that B is 14, C is 9, and angle C is 34 degrees. So angle C is an acute angle and side C is less than side B. Thus, you can compare side C to side B times sine C and find the number of triangles formed. Here's our solution. Since C is 9 and B sine C is 7.83, so 9 is greater than 7.83, therefore there are two triangles formed. So triangle number 1 and triangle number 2. So we will be solving triangle number 1 first. So in here, we're going to solve for angle B first using this formula. Sine B over B equals sine C over C. So substitute the values, cross multiply, divide both sides by 9, then solve for angle B using your calculator. So angle B is 60.44 degrees. To solve for angle A, we will use the triangle sums theorem. So substitute the values, combine similar terms, and subtract both sides of the equation by 94.44 degrees. So angle A is 85.56 degrees. Then we solve for the third side, which is side A, using this formula. Sine C over C equals sine A over A. So substitute the values, cross multiply, divide both sides of the equation by sine 34. So A is 16.05. So for triangle number 2, we solve for angle B using the measurement of angle B from triangle number 1. So subtract it from 180 degrees. So we have angle B is equal to 119.56 degrees. Then we solve for angle A using triangle sums theorem. We substitute the values, combine similar terms, subtract both sides of the equation by 153.56 degrees. Then angle A is 26.44 degrees. Then we solve for the third side, side A, using this formula. Sine C over C equals sine A over A. Substitute the values, cross multiply, divide both sides by sine 34. So A is equal to 7.72. So we have now triangle number 2. Let's proceed to our example number 4. LeBron, Stephen, and Anthony are playing basketball. Their current positions form a triangle with angle at LeBron equal to 51 degrees. If Stephen is 7 meters from Anthony and LeBron is 4 meters from Stephen, how far apart are LeBron and Anthony? The angle given is acute and the length of the side opposite the given angle is longer than the other side. Thus, there is exactly one triangle. So here is it. So let's assign variables. So let A be the measure of the angle formed at Lebron, B be the measure of the angle formed at Anthony, C be the measure of the angle formed at Stephen. Small letter A be the distance between Stephen and Anthony. Small letter B be the distance between Lebron and Stephen, and small letter C be the distance between Lebron and Anthony. So please take note that the problem is asking us the distance between Lebron and Anthony. So we are looking for C, side C. So to solve for the angle formed at Anthony, let's use this formula. And don't forget that we're looking for the distance between Lebron and Anthony. So to solve for angle B, we use this formula, sine B over B equals sine A over A. Substitute the values, cross multiply, divide both sides of the equation by 7. So sine B is equal to 4 sine 51 degrees over 7. We solve for B using your calculator. So angle B is 26.36 degrees. Then we solve for the third angle, angle C. So using the triangle sums theorem, substitute the values, combine similar terms, subtract both sides of the equation by 77.36 degrees. So angle C is 102.64 degrees. Then lastly, we can solve the distance between Lebron and Anthony using this formula, sine A over A equals sine C over C. Substitute the values, cross multiply, divide both sides by sine 51 degrees. So C is equal to 8.79. So therefore, Lebron is 8.79 meters away from Anthony. To summarize our lesson, let's have another look at the possibilities when two sides and an angle opposite one of the sides of a triangle are given. For our valuing, evaluate your mastery on the expectations stated at the beginning of this self-learning module. Have you achieved all the expectations set for this lesson? If your answer is yes, reflect on your study skills so that you can continue to use them. However, if your answer is no, what steps will you take to improve? To assess if you have learned something, let's answer your post-test and your activities. You may use the key to correction to check your answers.